Welcome to Rivera Institute of Mathematical Sciences. Today we are discussing some problems of linear algebra from CSIR November 2020. First one, let capital A and capital B be two n by n matrices, then which of the following statements are true? Here four options are given. This problem can be done by using eliminating the wrong options by taking examples. For that, here I choose capital A equal to 2 by 2 identity matrix, that is 1 0 0 1, and capital B is also 2 by 2 identity matrix, that is 1 0 0 1. Then what is A plus B? A plus B equal to 2 0 0 2, and A minus B is the 0 matrix, that is 0 0 0 0. Now what are the determinants of these matrices? That is determinant of A equal to 1, that is A is an identity matrix, therefore determinant of A equal to 1. Similarly, determinant of B is also 1, and determinant of A plus B equal to 2 into 2 4, and determinant of A minus B is the 0 matrix, therefore determinant of A minus B equal to 0. Now consider the four options. Here I consider first option, option A. Then what is the LHS of this option? LHS equal to determinant of A plus B, that is 4 plus determinant of A minus B, that is 0. That is 4 plus 0 equal to 4. Now consider the RHS. RHS equal to determinant of A plus determinant of B. Determinant of A is 1, therefore 1 plus 1 equal to 2. Both are not equal, therefore option A is false. Now consider option C. What is determinant of A plus B plus determinant of A minus B? That is LHS equal to 4 plus 0 equal to 4, and RHS equal to 2 times determinant of A. 2 into 1 minus 2 times determinant of B. That is 2 into 1, which is equal to 2 minus 2, 0. Here also both are not equal, therefore option C is also false. Now consider option D. Determinant of A plus B minus determinant of A minus B, that is LHS equal to determinant of A plus B 4 minus 0, which is equal to 4, and RHS equal to determinant of A plus determinant of B, that is 1 plus 1, which is equal to 2. Here also both are not equal, therefore option D is also false. Here only option B is true. The proof of this option will do later. Okay. Next question, let capital Q be a real quadratic form on R2, then which of the following is positive definite? Here capital Q is a real quadratic form on R2, so the corresponding matrix of this quadratic form will be a 2 by 2 matrix. First consider a quadratic form on R2, that is A x square plus B y square plus 2C xy. This is a quadratic form on R2, and the matrix corresponding to this quadratic form is capital A equal to A C C B, right? And this quadratic form is positive definite if the leading principal minors are greater than 0. What are the leading principal minors of this matrix? The leading principal minor of order 1, that is D11 equal to the first entry, that is A, and leading principal minor of order 2 is D22, which is equal to the determinant of the given matrix, that is AB minus C square. If both these leading principal minors are greater than 0, then the given quadratic form is positive definite. Okay. Now consider the four options. Here I consider option A. What is the matrix corresponding to this quadratic form? A equal to 0, 1 by 2, 1 by 2, 0. Okay. Now what is D11? D11 equal to 0, which is not greater than 0. Therefore this quadratic form is not positive definite. Now consider option B. What is the matrix corresponding to this option? Capital A equal to 1 minus 1 by 2 minus 1 by 2 1. Now what is D11? D11 equal to 1, and D22 equal to determinant of this matrix, that is 1 minus 1 by 4, which is equal to 4 minus 1, that is 3 by 4. Here both the leading principal minors are greater than 0, so this quadratic form is positive definite. Now consider option C. What is the matrix corresponding to this option? Capital A equal to 1 1 1 1, that is each entries are 1. Now what is d11? D11 equal to 1, which is greater than 0, and d22 equal to determinant of this matrix, which is 0, which is not greater than 0. Therefore this quadratic form is not positive definite. Now consider option C. What is the matrix corresponding to this option? Capital A equal to 1, 0, 1 by 2, 1 by 2, and D11 equal to 1, which is greater than 0, and D22 equal to 1 into 0, that is 0 minus 1 by 4, which is less than 0. So this quadratic form is not positive definite. Therefore only option B is true. Okay. Next one. Let capital A be a 2 by 2 matrix with a determinant of A equal to 1 and trace of A equal to 3. Find the value of trace of A square. Here the matrix is a 2 by 2 matrix, and we know that the sum of eigenvalues is the trace and the product of eigenvalue is the determinant. Here lambda 1 and lambda 2 are the eigenvalues of this matrix. That is, here capital A is a 2 by 2 matrix, so the eigenvalues are lambda 1 and lambda 2, and we know that the sum of the eigenvalue is trace, that is lambda 1 plus lambda 2 equal to trace of the given matrix is 3, and product of the eigenvalues are determinant, that is lambda 1 into lambda 2 equal to 1. Now what are the eigenvalues of A square? We know that if lambda 1 and lambda 2 are eigenvalues of A, then eigenvalues of A square is lambda 1 square and lambda 2 square. And what is the trace of A square? Trace of a matrix is sum of eigenvalues. Therefore trace of A square equal to lambda 1 square plus lambda 2 square. Okay. Now consider lambda 1 plus lambda 2 whole square. Okay. What is lambda 1 plus lambda 2 the whole square? Which is equal to lambda 1 square plus 2 times lambda 1 lambda 2 plus lambda 2 square. Okay, and what is lambda 1 plus lambda 2? Lambda 1 plus lambda 2 is 3, that is 3 square equal to lambda 1 square plus 2 times lambda 1 into lambda 2 is 1. 2 into 1 plus lambda 2 square, that implies 9 minus 2 equal to lambda 1 square plus lambda 2 square, which is equal to 7, that is lambda 1 square plus lambda 2 square equal to 7, that is trace of A square equal to lambda 1 square plus lambda 2 square, which is 7. Therefore option D is true. Okay.